Okay, we're in section 77 of the notes now. There'll be contents to look over, examples to do, and then exercises to get busy with. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra. It dates back to 1904. The PDF you're looking at now is being prepared for the prison mathematics project participants only. I realize other people may be watching these videos. If you are and you're interested in the document, you want to know when it's going to get published, just reach out to me. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right, let's take a look at the contents. And the contents, it looks like there are going to be problems related to arithmetic progressions. All right, so let's take a look. And as I do the problems, I want to point out to you that there's a couple things you do need to know. For example, you need to know that for an arithmetic sequence, and what I mean by that, there's going to be a sequence A1, A2, A3. So I'm going to say AN would equal A1 plus N minus 1D, where D is a common difference. So what do you get? It says the sixth term of an arithmetic progression is 5/6. So write down A6 is 5/6. They tell me the 15th term is 16/3. Now, what do I know about these terms? They're related to the first term, A1 plus N minus 1. Well, if N is 6, that would be 5D. And this is going to be A1. Well, N minus 1, well, it's 15 minus 1 is 14D. All right, so I have two equations with two unknowns in it. Let me erase this information over here. Let me write down 16/3 in terms of sixth. All right, so it's going to be 32/6. All right, what I'm going to do is I'm going to subtract these two. All right, so I guess I would do 5/6 minus 32/6, which would be 27/6, the opposite of that. And 5 minus 14 is 9. I think I know what D is now. D, let's see, it's going to be minus, 9 goes into minus 27 minus 3 times. So it looks like, I think I might have made a mistake somewhere. 5/6, 32. Oh, I'm sorry, I made a mistake. I got to correct it. I'm sorry, 32 minus 5 is 27/6. That was my mistake. A1 minus A1 is nothing. 14 minus 5 is 9. What's D going to be equal to? Well, 9 goes into 27 3 times, and 3 goes into 6 2 times, so D is a half. All right. Now, the question is, they want you to find the first term. So let me use this equation here to find A1. So what do you get? 5/6 equals A1 plus 5 times D, which would be 5/2, right? Well, I can get A1 now. A1 is going to be 5/6 minus 5/2 is equal to A1. Come down, it would be 6 there. And let's see what you get. You get 5 minus 15, which is minus 10. So A1 is minus 10/6, or minus 5/3. All right, let's go to the next one. Okay, I notice there's something wrong with this, and I'll tell you what's wrong with it. The solution's not being highlighted, and that would certainly confuse a lot of people, but this should be being highlighted, and I'll put that down later. I'll correct that. You're not going to see that part. All right, so let me go through the work, and kind of reading it, it says, find 4 numbers in an arithmetic progression such that the product of the first and the fourth. So I'm just going to write this one down. I'm going to write A1 down. I'm going to write A2 down, A3 down, and A4. All right, so it says find 4 numbers in arithmetic progression. Now, by the way, it doesn't have to be A1, A2, A3, A4, but I'm just going to make it 1, 2, 3, 4. And I'll just call the first one X, The next one's x plus d. The next one's x plus 2d. And the next one's going to be x plus 3d. And let's read it. What does it say? Find four numbers in an arithmetic regression such that the product of first and fourth. First and fourth. Let me write that down. So the product would be x plus 3d shall be 45. I'll write that down. And the product of the second and third, these two over here, I'll write that down for you. Is 77. All right, I got to be honest with you. Looking at these things, you might say, what am I going to do about this? I would say just simplify it. And what do you get? You get x squared plus 3dx equals 45. On the second equation, you get x squared plus, let's see what you get, 2dx dx, 3dx, plus 2d squared equals 77. What I would do now is I would probably subtract the two, because I'm noticing that a lot of things would disappear. Now let me do that. What are you going to get if you subtract the two? You get, and again, I'm going to take this one, subtract away this one here. So what do I get? I would get 2d squared equals 75 minus 45 is going to be, let's make sure I did that right. X squared 3dx x plus d, that's x squared plus 3dx. I'm looking for something that's going to be easy. That's why I say that. And 2 and 3, 3dx plus 2d squared. So that seems to disappear okay. Yeah, 30. So d squared is 15. All right, we got to find out something now, don't we? We have to find out the x in the problem. Let me just look back up here. And I think I might have made a mistake. Oh, I see what it is now. I wrote down 75 when it's 77, and that makes all the difference in the world. I got to erase this business over here. Sorry about that. The reason I was looking at that, the d squared, it really turned to be a very difficult number. And I'm kind of surprised to see that, actually. That's why I had suspicions about that. I'm going to go back to my subtraction now. So you can get 2d squared. And that's going to be what? 32, right? So d squared is 16. And d could be plus or minus 4. Well, I got a couple cases here, don't I? So I'm going to put this down. And I got to figure out the x in the problem. Now, so what equation I'm going to use? And I'm going to tell you I'm going to use this one over here. So I'm going to try d is 4 first. And what do you get? You get x squared plus 12x. Again, we're using this equation here. Equals 45. Well, I'm just going to subtract 45 from both sides. I'm going to try to factor it. Let's see. I'm going to say 15 and 3, right? So let's write this down. So if d is 4, x is going to be 3. If d is 4, x should also be minus 15. Don't be discouraged by having choice. Let's do the next one. Let's do d is minus 4 now. And again, we're still using this equation here to figure it out. What do you get? X squared minus 12x. I'll subtract 45 from both sides. And like deja vu all over again, except a little different. And what do you get? 15 and 3. Minus 15 plus 3. So write that down. Again, there's 4 choices now, right? So you get d equals minus 4. And the x could be minus 3. And And if d is minus 4, the x could be 15. I'm going to write this sequence down here. And again, the sequence is given. We know as a1 is x. So I'll write down 3. And then it's going to be 7. I'm doing this line here now. And it's going to be 10. It's going to be 13. Let me do this line over here. Minus 15. I'm adding 4 on. That's going to be minus 11. I'm adding 4 on. That's going to be minus 7. And I'm adding 4 on, and you're going to get minus 3. Let's do this one. What do you get? Minus 3, minus 7, because I'm adding minus 4 on, minus 11, minus 15. Let's do the next one. What do you get there? Minus 4. I'm sorry, that's not minus 4. I looked at the wrong thing. 15, 11, and then what do you get? You're taking 4 off it, right? So 7, and 4 off, and that's 3. You know what? I think I made a mistake in the first one. It's 3, 7. I see it now. It just, I look at these things, I was hoping for some, like, symmetry to the problem. So if you're adding 4, it's 13. I'm sorry, 11. And then you're adding 14 on, right? 15. So let's go back to the question, see what the question was. The question says, find 4 numbers in an arithmetic progression. So I'm going to say that they want me to find 4. It doesn't matter the order in which I write them down. So I say 3, 7, 11, and 15. That's certainly one choice. The other choice is going to be minus 3, minus 7, minus 11, minus 15. And notice this is the same thing, isn't it? Minus 3, minus 7, minus 11, minus 15. Works out pretty nice. All right, so we found the 4 numbers. All right, let's go to the exercises. Again, I want to emphasize over here, you're basically just imitating what we've done up here. I think that the big formula that we use over here is, AN equals A1 plus N minus 1D. I think that's going to bode well in the rest of the exercises. Now, there might be other ones. There might be a sum. I don't know. I'll take a look at it. Oh, yeah, I see a sum. So I'll write the sum formula down for you. Sn, that's the nth partial sum, is N A1 plus AN over 2. All right? Now, granted, there's problems. You want to be able to get through those problems. Let me just see if that was a sum problem. First, oh, no, that's not a sum problem. They're just saying the sum of the 6th and 10th terms. They're not in a term. Let me put it Sn is A1 plus A2 plus A3, yada, 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 up to AN. All right? That's not the second problem. Maybe it's not going to pop up. Oh, no, I do see it popping up right over here. I see the sum formula right there. Okay? So, yeah, I'm seeing it. So we need those 2 formulas. Let me go back to that. You need these 2 formulas. They're going to be important. All right? They're going to be important. All right, go through those problems. They're not easy. I did them. I worked through all the problems. I type it up, yada, yada, yada. Yes, it took me time and effort to get through it. No doubt about it. All right? They're interesting problems. That's what I like about his text. We got some really interesting problems. Especially things like this over here. I mean, you might read through that and have a tough time with it. That's part of it. Having a tough time is a good thing. This one, I put a little graph down there for you. This is another tough problem, I believe. 14. I have to read through that and try to make sense out of it. 15 looks pretty tough. 16, yeah, 16 was a tough one too. I remember doing that, but it was tough. It gets absolutely tough. 17, not that bad. 18, yeah, 18 is pretty tough. No doubt about it. I have to think about that one too. 19, also a tough problem. I had to think about it. All right. So what's the problem with thinking? It takes time. And a lot of people get frustrated when they have to think. They want something really simple. Okay, related Sage code. What's Sage? It's a computer algebra system, or a CAS for short. It's open source software. Go to this website. You can download or use the interactive web-based application. I got some code over here if you want to take a look at it. The real intent here is to get you to do the problems, though. And if you have any issues with the problems, you should reach out to me. I make errors. All right? If I make an error, I'll correct it. Like if you say I did problem number 19 wrong, write to me. Please don't give me the page number, though. Don't say it's on page 1386. Tell me you're in section 77.3. So this is section 77.3, and you're doing problem number 19. And tell me what's wrong with it. All right? If you think there's something wrong there, you know what? Maybe there is something wrong. Maybe I didn't read it correctly. Maybe I made a mistake in the arithmetic. Who knows? If you see something, say something. All right? Thank you.